So next is additional to the naming convention, because what we have seen is the file name can hold only so much of information, but there can be many others, or how to find those data. So in those case, you can use the metadata linking with the file or having suitable documentation to it. So what metadata means is it's a subset to the core data documentation, which will provide additional standardized information that's going to explain what is the purpose of the file, what is the origin of the file, what are the different time references that are built into it, and the geographic location, who is the author of it, and what are the access conditions, what are the access levels, what are the terms of use of those data collection, and so on. So this is the definition of the metadata information from the UK data archive. So putting into simple words, with this metadata information or documentation, what we can ensure is it can be easily searched for and can be quickly retrieved, and it can be understood in the present scenario and also in the future scenario what is the purpose of those data and what has been structured into it, and it can also be properly interpreted because we have the relevant information available within the embedded metadata. So these can be captured in two ways, that is using the Windows Properties tab or in the AutoCAD drawing properties. So in the Windows environment, what you can do is you can look into the additional properties that can be embedded as metadata information. So towards this, you can select the file, right click it and go to properties. So here you can see that this is your typical name, and then it also denotes what is the size and all. So this is normal information, but additionally you also have a summary information. So here you can give the title of this drawing, title of the drawing or the project, and what data it is subject, what are the author or what are the keywords by which you can search, and what are the comments to that particular file or particular version. And if you want to have any reference to it, then you can also create a hyperlink to this base. And AutoCAD also offers you statistics of it, when it was created, when it was modified. Okay, even opening and closing will also be counted as modified. And who was the user was created, what is the revision number to it, and what is the editing time. Also, you can give custom properties values. So these are custom metadata information that you can fill in. So you can give in the file name, the revision name, or the subassembly reference. All those things can be given as custom metadata information. Then you have the typical security information where you can restrict who can view the file, who can edit the file, and those. So it means that you are protecting the editing of the files. Then finally you have the details of it. But the data that of importance to us is the summary tab and the custom tab, by which you can enter the metadata information into it. Alternatively, in AutoCAD, for example, in this drawing, what you can do is in File tab, in the drawing properties, you can see it bears almost the same info here, the summary and the custom tab. So here you can add in the metadata information by which you can categorize the information. So next is looking into the controlling of the different versions of your file. So this is in fact a major topic because there are a lot of tools that are available that will help you in controlling the version. But let's look into what is typically version control means. So having a good version control will help us in tracing the document or the file. So what traceability means is it a retention of all the drafts and the details of the changes that are made on the file, and also the order of the changes, so that we can know which is what and when it has been created or modified. Next, also we have the identifiability. We can know that what is the current version that we are working on and who has done what revision and when. And also we can have clarity to it. That is, not only with the revision number versions and the levels, The latest version can be taken and pulled easily, and we can know that this is the current version, this is the previous version, and this is a deleted version, so on and so forth. So we have clarity of the file version that we work on. So next we can helpful in reducing the duplication of it. It means that only the definitive versions that are required for is retained and others can be discarded. And as you have a very strict version control, you can also reduce errors that are built into it. It means that the release version can have only limited access in order to avoid changes. So what we have seen earlier is we have looked into detailing of the versions into your file name nomenclature itself. But what this version control means that you typically work with a single file and then you overwrite the existing versions. That is, you have a single working copy of the file and all the previous versions will be indexed into the version control management so that you have the only the current version that is working on and not the previous ones. And only if required, you can pull in the previous ones. So it means that it simplifies the process of your working and the naming. So typically, you can take it in a simplified manner without any tools, and so you can have a version control table wherein you specify the version number, you denote who is the person making the change, and also include what is the purpose of the change or the change detail and date of the change. So what you can do is you can position this information as a text file, or simply put, a better way is putting as an Excel file into those respective folders that have the drawings in place. So it means that you have a track of all the changes that been made into this file, and hence without opening those files, you can just open this Excel sheet and look into which revision that you want to work on and what are the previous versions and so on. And also it can help you identifying the file that is required for you. So it means that you're bringing all the information, that is, you're bringing in your file name, you're bringing in your purpose, you're bringing your metadata information and all those things, and also with the versioning of different modifications so that you bring it all together in a single location to have a well-defined version control in place. So alternatively, you can also use version control tools. There are a lot of ready-made softwares that are available for CAD versioning, that is your design drawing versioning, but typically it all does the same actions. So what it does is, it's a system or software that is going to record the changes that are being done to a single file or a set of files. It means that you always work on a single file, and then all the changes that are done need not be created as a separate file or a separate thing. It can be kept as a working copy, and all the revisions will be recorded automatically into the system. So any previous versions that we're working on will be stored internally into the version control tool, and hence you can pull it out at any point of time you want. And also the current version can be branched out. Branched out means creating a working copies between the different collaborators. That is, all the persons will work on the same working copy, the same project. Then they can be merged back into the master copy and then continue. So what it means that you are splitting the drawing into the components. That is, you work on this designated areas and then you can pull it back into it. So this kind of merging activity cannot be done in a normal version control tool, but in CAD version management tools that are available in the market, you can do this activity. So it means that it will quickly show in what are the differences that are being done with the previous versions and so. Also, when you're merging back the data, suppose two persons have done modification to the same object. Suppose one person has defined a diameter of 8 mm to the drawing, whereas the second person has defined a diameter of 10 mm to a drawing. When it is merged back, it will show up a conflict option between the version, and hence the manager or the supervisor can decide upon which property to be taken into. That is either 8 mm or the 10 mm to be retained. They can review it and then take it back. So it means that any unauthorized changes are not done to the main drawing. So you can also view the differences between the different versions that we have. In AutoCAD, inside the tool itself, we have the drawing compare option so that we can compare two drawings simultaneously and see what are the differences that are called for. So it means that you can use the custom or the typical free open source tools that are in the market currently for your training purpose. You can see how this version control works, and then in order to dwell deeper into the design changes, then you can use the AutoCAD DWG compare to view the differences. This is how the version management tool looks like. So all the version control tools have a single repository. So this repository means like a folder kind of thing, the main folder, the bank, a locker kind of thing. So wherein for working, you take the copy of the current file, that is the working copy. So this is collaborator 1, 2, 3. So all they take a working copy of that. Okay, so any changes that are being made within, suppose this author, does a change. So what he does is he will commit the change to the repository. So typically first he pulls the data, then he pushes back to the repository. So now the users here, they will get a information automatically saying that the original file with which they have a working copy on has been modified. So then they can update the working copy accordingly. So then they also internally have a conflict. It will show that this property has changed. So they can accept whether they have to work on it or not. So thereby they update the drawing and then push it back to the central repository. So typically this is how almost all the version control tools work in. So there are two popular examples in it. SVN, the subversion control, or the JIT. So for SVN, you have the Tortoise SVN, and JIT, you have GitHub, that is an online portal. So my recommendation is to use the subversion controlling, have a good grasp of it, how you can control the documents to it, how you can look into the changes. You will have to, check in the document, check out, update, commit, and then look into the different variances. So this is an evolving process. This is a subject altogether on its own, but I would recommend you to use these tools in your normal practice sessions so that you can have a way around it, because whatever product lifecycle management tool that is going to be used in the organizations is all going to be based on this single functionality. So this sums up the different version control tools that are employed in the organizations. So this concludes the different file management techniques that we have looked into. So we have looked into various file nomenclature techniques, folder nomenclature technique, and the version controlling. So please bear it in mind. You have to have all these in place. It is a discipline by which you have to maintain those names and structures, because it will make your life easier and it will make you more productive. So now we'll see into what are external references, or XRef to be in short in AutoCAD. So external references and blocks are kind of close to each other, but only thing is, like, when a drawing is going to be inserted as a block, then the block definition and all the associated geometry are going to be stored in the current drawing database. That is, if you're working in this drawing, then whatever block that you're inserting will be pertaining to this drawing only. Whereas the block is not going to be updated if the original drawing changes. But if you are going to use as an external reference, that is, you insert a drawing as an external reference, then whatever you are doing in this drawing, the external reference will get updated when the original drawing file itself is changed. That means all the latest revisions to the original drawing file will get reflected to the attached reference drawings in the other drawings. So this is the major difference between your blocks and external reference. So typically, to put it short, the drawing that's going to contain your external reference will always have the latest editing of the drawing that you have. Okay, so this is what the external reference is highly used for. So this comes in place when you are working with an assembly drawing where you have multiple persons working on the drawing. It means that each and every sub-components are being developed by different persons, but later you're bringing all together into the single drawing to produce a output an assembly drawing. And suppose in the due course of the drawing, one subcomponent gets updated, then you need not have to track back and then update in your final assembly drawing, but rather it's all carried forward together. So that is the external reference. So typically what you're doing is you're creating a link between the subassembly drawing as well as the assembly drawing through the external references. So this external reference is going to be a variation of the block. So a block that we have done is going to be a collection of geometry that is identified by a unique name and is stored in the symbol table as we had seen earlier in the block. We'll quickly show. So when in the block, you can see that. Okay, let me go in the insert block. So here you can see that it's a collection of this geometry that is going to be stored as a unique name as well as a symbol table, so that when you insert it, it will act as a single entity. However, when we are going to take the blocks, the external references, the geometry associated with the external reference definition will not be stored in the current drawing. It is stored in the original file only. So this sums up the basic definition behind an external reference. We'll quickly jump into how to use an external reference. So towards it, you can see this drawing. This is from the AutoCAD mechanical database. So this is a pump housing. It's an assembly drawing. So here you can see the various distinct elements of this assembly. So we have a long hexagonal socket head cap screw, and then we have the bottom plate. This unit has a bottom plate, and then this plate has the pump cover, and then we have a drive shaft, and then a wheel casing in between, and also a pump wheel in between. So you put these all together along with the deep groove ball bearing elements in these two. So now you get the complete gear pump subassembly. So let's see how to include all the subassembly drawings into a major drawing inside. So towards this, you can call the external reference through either the insert tab and then external reference, or in the insert tab, here in the reference panel, you have the external reference as the attachment here. So these two ways of inserting a external reference. So we'll go with the insert and external reference. So once you do that, we'll get the external reference display manager. The external reference manager, just quickly open it up. So here we can see the entire details of the drawing. So currently what we have seen is the current drawing that is taken as reference here. And then we have the option to attach a drawing. Okay, so once I click on that, you can see except for this subassembly pump, we have the individual components. So let us go with the first one, let us say the pump cover. Click on open. Now comes the attach external reference tab. So just like in block, you can see that we have the scaling option, insertion option, and the rotation, the block units, and so on and so forth. Along with it, we also have a preview of it, and also a reference type that comes in. That is, you can either external reference as an attachment or an overlay. So overlays are typically used when you need to view another drawing geometry temporarily, but we do not plan to plot using that data. It means that it's kind of a tracing paper that is on top of our current drawing. We're just placing out the new drawing that is taken as an external reference just for a temporary viewing. So in those cases, we use this for overlay. So whereas if we do as an attachment, then it's going to be a single one-time occurrence for this external reference, and that's going to be for permanent use and also can be used for plotting the document view. So the process is all the same, but only the differences is how this nested reference is going to be handled. So that nesting means it's going to occur when an external reference drawing contains a reference to another drawing, so that it is either visible in the current drawing or an overlay to the attached drawing also. So let us quickly see how different it is. Like, let us go ahead with the overlay, click on OK. Now let us click on this insertion point. You can see that. Okay, so let us quickly insert using this command XRef the next component using this attach tab. Now let us go for the pump wheel, but this time let us insert as an attachment. So now how it's going to vary is between the attach and the overlay is that when you're saving this document and then using this drawing as a reference to another drawing, then you can see how the attachment or and the overlay is being affected. So to quickly understand it, let's just look into here. So you can see this pump wheel, it has been taken as an attachment, whereas the pump cover, this one has been taken as a overlay. So it means that we are using this pump cover as a overlaid reference only for this drawing, okay, and you do not intend to use this as a part of this drawing when you're saving and then using it again. Whereas this pump wheel has been taken as an attachment, so it will be used as an integral part. So what we can do is we can just quickly save it out, and then we'll create a new drawing. And now let's again call the XRef. Okay, so in this drawing, let us open up the drawing 3 that we have created. And now we'll again use it as an overlay only because we do not want to have it as an attachment. We just want to have it as a reference. Okay. So now clicking on OK and clicking the insertion point here. Let me zoom back to the extents. You can see that only the pump wheel has been taken because this is an attachment to this drawing 3. As you could recollect, in drawing 3 we didn't have any drawings that we have construed by ourselves. We had directly attached two external references as an attachment and an overlay, and that difference is called upon when we are referencing this file to an X file. So this is the basic difference between an attaching and as an overlay or an attachment. So to quickly reiterate the functionality of this XRef is that we can use this to coordinate our work with the others of others by referencing others' drawings in our drawing so as to keep up the changes made by other designers. We can also assemble a master drawing, that is the overall assembly drawing with different subcomponent drawings that may not be the final one, but as an interim one using which you can, based upon your drawing. So that to simply say, you're working on a part that needs to have the dimension boundaries by a component that is worked upon by a different designer. So in that case, you need not wait until his design gets to process through all the changes. So once that design has crossed the interim stages where the boundaries are defined or the reference points are defined in that drawing, then you can take that as an overlay onto your drawing and then use that for your building on your drawing. So this is the major usage of this external reference. Also, one more thing is when you're construing the final drawing, you can always ensure that the most recent version of the reference drawing will get displayed. So every time we open up the drawing, so what happens is AutoCAD tries to refresh the location. Okay, so it will go back to this location, refresh the drawing again and again whenever you open this. So whatever the latest update of the individual drawings will get updated to your external reference one. Also, what it does is it will take forward all the layers that are predefined in the existing drawing so that it retains the names of the layers, the dimensioning styles, the textiles and all other elements from the original drawing to your current drawing so that they are not affected. Also, if required, we can bind the attached reference drawing permanently to the drawing when the project is complete and is going to get launched or reviewed. So that we'll look into shortly. So now let us again quickly look into what are the different options that we have here in this external reference tables here. So what we have seen is we can attach as a drawing. Also, we can also attach as an image or a PDF file or any point cloud or coordination model. So what it does is it did not need to constrain yourself with a certain file type for creating a drawings. So with a different sorts of requirements, you can pull in and then reference it to it so that you can quickly work on your drawing and collaborate more effectively. Also, you can see that for each drawing that you're loading onto it, it'll show whether it has got loaded or not, what are the size of the individual drawings, and what is the current type of the attachment it is, so either an overlay or an attachment, the date of creation of the drawing, and then what is the location of those drawings. So these all get filed under this file references. So this is how the nesting will happen. Nesting as in like this drawing 3 comprises of pump wheel as an attachment. On the symbol you can see what's the difference is. An attachment wears the drawing symbol so that it's going to carry it over, but an overlay is just kept upon your drawing here. So this is your overlay symbol. Whereas in drawing 6, you have the nested reference here. That is, you have a drawing 3 as well as the pump wheel. So there also runs a certain risk of circular referencing. If you're aware of Excel terminologies, circular references is used when the drawing that refers to a secondary drawing that in turn refers to the primary drawing. So in that case, if you have such kind of dimension, then there is an issue of that. So hence, as an attachment is always not a recommended part of importing if you are using only for reference. So always try and use for an overlay option when you're using the XRefs. So once you have imported to this drawing, then again you can also modify the type by right clicking on it and then selecting the XRef type as either the attachment or overlay. As you can see, now we are in the drawing 6 and it is in the original drawing 3, and that's why we are not able to modify it. So the explanation also is given here. That is, for nested references that is selected, the pump wheel is a nested reference and hence we cannot change the path or the name or type. All the modifications have to be done in this drawing, only then it will get updated here. So suppose if we modify this as an overlay and then save this drawing and now get back here. So now we can see that AutoCAD prompts that you need the external reference source file has changed and may require reloading. So once you reload, you can see that that goes off because we have taken as an overlay and hence that is not listed here. So that is the major difference between an attachment and an overlay. So also now we can go ahead and then we can try and detach the drawing from here. So selecting on this, you have an option that is unload reload option. So unloading means the file is still attached to the drawing, but it's not referenced to the drawing internally. So that is let me dock it out. Okay, so now what happens is we have unloaded the drawing. However, it is still attached to this as an external reference. Clicking on reload will get it loaded again, but clicking on detach, it will go into totally eliminate or remove the external reference from the drawing. So what it does is AutoCAD will erase all the XRefs copies, deletes its definitions, removes all the XRefs from the tree and list views, all the information such as layers, line types, everything will get deleted. You can see here now the layer information of that is also getting deleted. So you totally remove all the references of that particular drawing that you have attached from the drawing. So this is what is the detaching of XRefs. However, in case of nested references, we cannot detach or we cannot detach the top level external reference if it's going to be a nested XRef. So you always have to go to the original XRef. The nested means this file is getting called onto another file and so on and so forth. So that is the detaching the externals, and also we have seen unloading an external reference. So what happens is it's removed from the display, and also one more thing is like once the job has been completed, that is once we have used this reference, let me say it. So suppose we are drawing a component, okay, so that has to get reference from this point of dimension. So we have considered this component, and now I do not require to load this component each and every time, but still have to have this reference in the memory as in the drawing, so that I can know where this reference comes from. Okay, so in those case I can do the unload operation so that my AutoCAD drawing opens up much faster and also uses lower memory, so that I'm optimizing it here. But the pointer to the reference will always remain here. So by this we can understand where it is used and why. So again, when we want to analyze where it has been a reference for, then you can use the reload option to look back, retrieve all the information that you are using it here. And also suppose if the original drawing has gone to any revision as we seen earlier, you can either reload it here or use the refresh option. So by that you can refresh all the location. Suppose if the referenced file has been moved over to a different location, it is not in here, then AutoCAD returns a prompt error saying that the file is not found. So in that case, you can select and then change the path type, that is make a relative or select a new path, or also go here and to select the path reference. Alternatively, you can also replace this component by a new drawing. Suppose if this pump cover, this references can be replaced with a different path. So this is about linking the address of the reference drawing. So this is about external references.